When you picture our solar system, what comes to mind? You probably think of the sun, a bright, burning star at the center of everything. Then you imagine the planets, rocky worlds like Earth and Mars, and gas giants like Jupiter and Saturn. These are the familiar places we see in pictures and, well, they feel like our cosmic neighborhood. But what if I told you that this is just the beginning? Our solar system is vastly larger than we often imagine, and there is so much more to see. Beyond the orbit of the last planet, Neptune, lies a darkness filled with mystery. It's a region we are only just beginning to understand, a place where the sun is just a distant bright star. Out there in the cold and the dark, our solar system keeps its oldest secrets. This is the great beyond, a frontier that stretches far further than any planet. Imagine traveling past Neptune. You would enter a realm unlike any other, where countless icy bodies drift silently through space. They are the leftovers from the birth of our solar system, and they've been there for billions of years, untouched and unchanged. These frozen relics hold the clues to our own origins. They can tell us how the planets formed, and, who knows, they might even explain how water arrived on Earth. We are explorers, standing at the edge of this vast, unknown territory. This outer darkness is not empty. It is home to two enormous distinct regions. We call them the Kuiper belt and the Oort cloud. These names might sound strange, maybe even like places from science fiction, but they are real. They're a fundamental part of our solar system's structure. The Kuiper belt is a donut-shaped ring of icy objects that begins just beyond Neptune. The Oort cloud is something else entirely, a giant spherical shell that surrounds everything, enveloping the entire solar system like a massive bubble. Let us begin our journey to the outer solar system. We must first travel past the familiar planets. We leave behind Earth, Mars, Jupiter and Saturn. We even fly past the distant ice giants, Uranus and Neptune. It's here, beyond the orbit of the eighth and final planet, that we cross an invisible threshold. The sunlight out here is incredibly faint. The sun is no longer a large, warming disk in the sky. It has shrunk to a brilliant star-like point of light. It still provides some illumination, but its warmth is almost gone. The temperature plummets to unimaginable lows, hundreds of degrees below freezing. This is the twilight zone of our solar system, the beginning of the Kuiper belt. This region is not a sharp, defined line. It's a gradual transition into a different kind of space. The Kuiper belt begins at roughly 30 astronomical units from the sun. 1 astronomical unit is the distance from the Earth to the sun, so we're talking about a distance 30 times farther from the sun than our own planet. It's a staggering distance to comprehend. Light itself takes over 4 hours to travel from the sun to this point. When we look at this region with our telescopes, we're seeing it as it was hours ago. It's a place where time and distance stretch our imagination to its very limits. This is the true beginning of the great beyond. This cold, dark expanse is often called the trans-Neptunian region. That simply means beyond Neptune. It's here that the Kuiper belt resides, like a vast, flat donut of icy debris. It extends from Neptune's orbit out to about 50 astronomical units. Imagine the solar system as a flat disk, with the planets orbiting in neat circles. The Kuiper belt follows this same pattern. It occupies the same plane as the planets. It's a continuation of the solar system's structure, but populated by very different objects. Instead of planets, we find countless smaller bodies, all made of ice and rock. They're the frozen leftovers from when the planets were first forming. Why is it a belt? The shape is a direct consequence of its formation. During the early days of the solar system, this region was filled with material. There was likely enough stuff here to form another planet, maybe even another ice giant like Uranus or Neptune. But the immense gravity of nearby Neptune stirred things up. It acted like a cosmic bully, preventing this material from clumping together into a single large world. Instead, the material was scattered into a wide, flattened ring. These countless small bodies were left to orbit the sun in a perpetual state of arrested development, a belt of failed planetary building blocks. The Oort cloud is one of the most mysterious concepts in astronomy. It's named after the Dutch astronomer Jan Oort, who first proposed its existence back in 1950. He was trying to solve a puzzle related to comets. He noticed that some comets, known as long-period comets, came from every possible direction in the sky. They weren't confined to the flat plane of the planets and the Kuiper belt. This suggested their source must be a huge spherical shell surrounding the entire solar system. It couldn't be a belt or a disk. It had to be a sphere. This was the brilliant insight that gave birth to the idea of the Oort cloud. Unlike the Kuiper belt, which is a relatively flat donut, the Oort cloud is a colossal sphere. It completely envelops the sun, the planets, and the Kuiper belt. It's kind of like a giant, thick-walled bubble marking the outermost boundary of our solar system. Its sheer size is, honestly, mind-boggling. The inner edge is thought to be somewhere between 2,000 and 5,000 astronomical units. The outer edge might extend to 100,000 astronomical units, or possibly even farther. At that distance, you're about a quarter of the way to the nearest star, Proxima Centauri. You're hanging onto the sun's gravity by the thinnest of threads. This is the true edge of the sun's empire. Why is it so mysterious? Because, well, we've never seen it. Not directly. The objects within the Oort cloud are incredibly far away, small and extremely faint. They're thought to be similar to Kuiper belt objects, but they're spread out over a volume of space that is trillions of times larger. The distance between each object is immense, likely tens of millions of kilometers. Finding one would be like finding a single grain of sand in a desert the size of a continent. Our current telescopes, powerful as they are, simply can't detect such small dark objects at such extreme distances. Its existence remains theoretical, inferred only from the comets it sends our way. The Oort cloud is therefore a ghostly prediction. It's a necessary component to make our models of the solar system work. Without it, we can't explain where long-period comets come from. Scientists are confident it exists based on the strong indirect evidence. But it remains an unseen, unvisited realm. It's a scientific frontier in the truest sense of the word. It represents the largest and most enigmatic structure in our solar system, a spherical cloud of icy bodies that has been waiting in the darkness for billions of years, occasionally reminding us of its presence by sending a spectacular comet to visit our inner neighborhood. To truly grasp the difference between the Kuiper belt and the Oort cloud, we must first talk about distance. The numbers involved are so large they can be hard to picture. So let's use a simple scale to help. Imagine, just for a moment, that the sun is the size of a football placed on the goal line of a pitch. On this scale, Earth would be a tiny grain of sand about 20 meters away. The final planet, Neptune, would be another grain of sand over 600 meters from the football. This is where the Kuiper belt begins. It's already a vast distance, far beyond what we consider our local planetary neighborhood. It's a journey our fastest spacecraft take a decade to complete. The Kuiper belt itself occupies a significant stretch of space on this scale. Starting from Neptune's position at 600 meters, it extends outwards to about 1,000 meters from our football-sized sun. It's a wide, sprawling ring, but it's still fundamentally connected to the planetary system. It's the known, mapped-out backyard of our solar system. We've even sent probes there, like New Horizons, which gave us stunning close-up views of Pluto. The Kuiper belt is remote, but it's within our reach. It's a frontier we are actively exploring. Now let's try to find the Oort cloud on this same football pitch scale. We have to leave the stadium entirely. We have to walk past the car park and just keep going. We would need to travel about 400 kilometers away from our football sun to reach the inner edge of the Oort cloud. That's about the distance from London to Newcastle. The outer edge would be even farther, perhaps 20,000 kilometers away. That's halfway around the real Earth. The Oort cloud isn't just farther than the Kuiper belt. It exists on a completely different scale of distance. It operates in a realm that makes the entire planetary system, including the Kuiper belt, look incredibly small and compact. This immense difference in distance is the most fundamental distinction between the two regions. The Kuiper belt is the solar system's outer suburb. The Oort cloud is a distant, continent-sized wilderness that surrounds the entire city. Light from our sun takes days or weeks to reach the Oort cloud's inner boundary. It would take over a year for that same light to reach the cloud's outer edge. Our fastest spacecraft, Voyager 1, has been traveling for over 4 decades and still won't reach the inner edge of the Oort cloud for another 300 years. It's a place defined by an almost incomprehensible emptiness and distance. The influence of the Kuiper belt and the Oort cloud may extend far beyond the outer solar system. In fact, they may have played a crucial role in shaping our own planet and making it habitable. During the early history of the solar system, a period known as the Late Heavy Bombardment occurred. This was a time, roughly 4 billion years ago, when the inner planets were pummeled by a storm of asteroids and comets. Many of these comets are thought to have been dislodged from their original homes in the regions we now know as the Kuiper belt and the Oort cloud, sent hurtling inwards by the shifting orbits of the giant planets. These ancient impacts, while destructive, may have been a vital delivery service. Earth is thought to have formed relatively hot and dry, too close to the sun for water ice to easily condense. So where did our planet's vast oceans come from? One of the leading theories points to the sky. Comets, which are essentially giant dirty snowballs, could have delivered a significant portion of Earth's water. As these icy bodies from the outer solar system crashed into the young Earth, they deposited their water onto its surface. The very water you drink today might have once been part of a comet that traveled from the solar system's deep freeze. But comets may have delivered more than just water. As we have learned from studying them, they are also rich in organic molecules. These are the carbon-based compounds that form the essential building blocks of life as we know it. Amino acids, the components of proteins, have been found in meteorites and detected in the comas of comets. It is plausible that the intense cometary bombardment billions of years ago seeded the early Earth with the raw chemical ingredients necessary for life to emerge. The Kuiper belt and Oort cloud, therefore, might not just be the source of our water, but also the source of the spark that ignited biology on our world. This perspective transforms our view of these distant, icy realms. They are not merely cold, desolate wastelands at the edge of our solar system. They are deeply connected to our own story, to the very origin of our oceans, and potentially of life itself. The history of Earth is not isolated. It is intimately linked to the history of the entire solar system. The chaotic dance of planets and the subsequent rain of comets from the Kuiper belt and Oort cloud may have been the precise architectural process required to build a habitable world like ours. Studying them helps us understand the delicate chain of events that allowed us to be here. As we stand here today, on May 24th, 2024, our exploration of these icy frontiers has only just begun. The flight of New Horizons past Pluto in 2015 was a watershed moment, transforming a fuzzy point of light into a dynamic, complex world. It proved that the Kuiper belt is filled with active, fascinating places waiting to be explored. But that was just one object among trillions. The future of exploration holds the promise of dedicated new missions designed to survey this region more comprehensively. Imagine orbiters sent to circle dwarf planets like Makemake or Haumea, or even landers designed to touch down on their frozen surfaces, drilling into the ice to read their 4.5 billion-year-old history. The Oort cloud, however, remains a much greater challenge, a frontier that will test the limits of human ingenuity for generations to come. We cannot currently send a probe to visit it in any reasonable time frame. The distances are simply too vast for our current propulsion technology. Its exploration will likely continue to be indirect, conducted through the patient observation of the long-period comets it sends our way. But with ever more powerful telescopes, like the James Webb Space Telescope and future ground-based observatories, we will be able to analyze these messengers in unprecedented detail. Each new comet becomes a new mission to the Oort cloud, a free sample delivered from the edge of everything. Perhaps one day we will develop technologies that make the journey feasible. Concepts like solar sails, fusion rockets, or other advanced propulsion systems could one day shorten the travel time from centuries to decades. A true interstellar precursor mission, designed to reach the Oort cloud and cross into the space between stars, remains a dream for now, but it is a powerful driver of innovation. Such a mission would represent a monumental leap for humanity, our first physical step into the galactic neighborhood. It would be a journey not just of scientific discovery, but of profound philosophical importance, as we finally leave our native star system behind. The story of the Kuiper belt and the Oort cloud is far from over. In truth, we have only just read the introduction. These vast, frozen realms hold the answers to some of our deepest questions about where we came from and whether we are alone. They are a reminder that even in our own cosmic backyard, there are still great unexplored wildernesses filled with mystery and wonder. The next discovery, the next breathtaking image, the next piece of the puzzle is out there, waiting in the cold and the dark. The journey to the edge of our solar system is a journey into our own past, and its future is an open invitation to explore.